We had a number of problems coming from, for example, corners. We quickly came up with a number of problems. They can do the number of legal moves on with just a one element on both sides, instead of 4, and then 2 elements there and 3. So you can ask yourself, if I have a square on both sides of size n by n, how many legal moves would there be? What configurations are legal or not? That's a quick question that you can start asking. If there are games that you come up with that can have ties, so you came up with a game that you can have ties, you can write down, under what conditions will I get a tie? What configurations will lead to ties? So there's a quick mathematical question that you can have. If you can't figure out some of these mathematical questions, what they usually do in math papers is they set up the results that they have themselves. You'll see like an introduction. There's no methods that's missing from math papers. You just have, here's my results of what I'm doing, theorem, theorem, theorem. And then at the end, they'll say, oh, by the way, for future work, we didn't work on these problems. Student papers are really great because they'll be accessible to you, and then you can figure out, things from that. So if you look in Fibonacci Quarterly or a MathSciNet, you'll start to find papers there. And if you can't access the papers, send me the paper you're looking for. I'll get the paper to you. So then you can look, and at the end of it, you'll find questions. So you want to start playing with that as soon as possible. So you need time. That's the part you need time, just to fool around with it and see what you can get. And the first method, not everybody works the same. Some people are automatically deductive reasoners. They just sit down and they sit and stare into space, and they gain some theorems doing it, conjectures doing it this way. I was always someone that started out small with something I could get my hands on, and then started working experiments. So I call it experimental mathematics, to come up with patterns. And so that's always one thing you can do, make the problem small enough where you can list out all possibilities like we did in class. So you're really using some of the same techniques we did in class to derive conjectures. And that's what you want to start. And you're always after a formula. L of mn is equal to m to the n. You just want a formula sitting there that gives you that answer. So any questions about this? I bet you never had such an open class before, right? One of the tools you'll want to use is you want to figure out how to express this as a graph. So for the game Go, you can represent the game Go. If you're looking at your crotch, I'm hoping that you're now looking at your cell phone. So please put your cell phones away. If you're not on your cell phone, you're looking at your crotch, you have some other problem. So if you have the game Go, you define G of Mn to be the directed graph whose vertices are the legal. So you need a list of all legal positions first, and they're the m by n positions which have a directed edge from P to Q. Wherever a white or black move from position P results in position Q, that's not the same as position. So you can't come back to position P itself. So what I'd like you to do is to list all positions, all possible positions for 1, 2, Go, and then cross out the illegal positions, and then draw the graph. So here's 1, 2. It's just a line like this, and these are the empty spots to put things on, like so, right? It's real quick. You'll not get too many things. So you can either put, for example, here's a legal position. I could have a black right there, or a purple. Right? So it won't take you that much time. So list out all the legal positions. And in this case, empty is a legal position. Empty will be a legal position. Is there, by the way, we can start here just to give you an idea what to do. Is there a way to move from this to this?
Yes.
You can put the black on this corner, right? So there will be a directed edge from this vertex to this vertex. Is there a way to get from here to here? Yes. Right? White could pass, so black has this. White could pass. Black puts this down here and suicides down to this. If both edges are taken by black, black suicides and ends up right back here to an empty graph. Or empty board. So it is possible to come back down.
So if black has both spots,
it's called a suicide. If black has,
so they just like disappear.
Yes.
Who takes them? White?
No.
No one. They just
So
move
they
off.
just go back.
Yeah.
Yeah, it just goes back to here.
So you want us to write all the positions and then like the arrows.
And draw the arrows, right. And you can work in pairs. I recommend it.
So you want us to also list the illegal positions too, right?
Yes, I don't, let me think if there's any illegal positions. Yeah, of course, the two blacks on the right, right. Two blacks will default into this.
And when black
And the black and white is also
and then
illegal.
also be flipped.
Black and white is illegal, but you can move from, so the way it works is you're writing, once you write down the illegal positions,
You can still draw the arrow.
you can draw the arrows that will
And then
get
you
you
can
to
go back
the
up.
illegal position, because that wipes it out,
Yeah.
right.